The students, this is question from May June 19, variant 43, question number 4. Question on connected particles. Two particles A and B of masses 1.6 kg, 1.3 kg and 0.7 kg respectively are connected by the light inextensible string, which passes over a smooth fixed pulley. Particle A is 1.75 meter above the floor and the particle B is 1 meter above the floor. See diagram. The system is released from rest with the string taut and particles move vertically. When the particles are at the same height, the string breaks. Show that before the string breaks, the magnitude of the acceleration of each particle is 3 meters per second square and find the tension in the spring. So in this case, the pulley is smooth, so tension throughout the string would be the same. So the tension is T newtons. The tension is T newtons here. And relative to B, I should mark it away from B and away from B. So here is the weight. Weight of B is 7 newtons. And the weight of A is 13 newtons. Let acceleration of the particles is A meters per second square. Same acceleration because they are connected. So this particle is coming down is A meters per second square and this is moving up. So this is again A meters per second. So acceleration is common because the string is light and extensible. And let the tension in the string is T newtons. So question is find, show that the magnitude of the acceleration is 3 meters per second square. Here, for the two particles, you can discuss the particles separately. We'll be using Newton's second law for this particle and for the other particles separately, for the acceleration and for the tension. So for 1.3 kilogram mass, for 1.3 kg mass, which is A, as it is moving down because of it is heavier. So use F equals to MA. F equals to MA. So force in the direction of motion minus upward. So as moving down, 13 minus T. So 13 minus T is equals to 1.3 A. And number one, weight is mg, and so mg has the value 10, and so the weight of A is the mass multiplied by 10, which is 13 newtons, and the weight of B particle is m into 10, so 7 newtons. Just for your understanding. So second particle is moving up. So moving up means the force in the direction of motion is T minus 7. So for this other particle, which is 0.7 kilogram, as moving up, again F equals to MA, force in the direction of motion is T minus 7 is equals to 0.7 A. Number 2. Solving these two equations for A and for 2. Solving 1 and 2 from 2, T is equals to 0.7 A plus 7. We put this value in equation number 1, which is 13 minus bracket 7.7 A plus 7 is equals to 1.3 A. 13 minus 0.7 A minus 7 is equals to 1.3 A. So 6 is equals to 1.3 A plus 0.7 A. And finally, 6 is equals to 2A. A is equals to 3. So acceleration is 3 meters per second square. For the tension, first one. Put a equals to 3 in any one of the two equations in 2. 2 is t minus 7 is equals to t minus 7 is equals to 0.7 into a. T minus 7 is equals to 0.7 into 3. T minus 7 is equals to 2.1 and T is equals to 9.1. So the answer is the tension in the string is 9.1 meters. So this was part A for 4 marks. So question was before the string breaks. When the particles are at the same height, the string breaks. So this is the activity before the string breaks. So separately, you can give the particle with the particle separately and use F equals to ma and F equals to ma. In this way, you can form two equations, solve them simultaneously. So for F equals to ma, F is the net force, force in the direction of motion minus opposite forces, and 13 minus in the first case and T minus 7 in the second case. So simple. Second is find the difference in the times that it takes the particles to hit the ground. So obviously, after the string breaks, the both particles will come to the ground. So the question is find the difference in the time. The string breaks when the particles are at the same height. So I'm going to erase this because this was the working for first part and just show the distances here. So I'm going to clear this figure. Now, here, when the particles are at the same height, so you'll have to now observe the height of B is 1, the height of 1.3 kilogram is 1.75. So the difference of the height is 0.75 meters. This is the difference of the heights. The question is when the particles are at the same height, the string breaks. So in order to get the same height, it should move, so halfway. So 0.75 divided by 2 is 0.375. So for the same height, this particle should be here and the other be here. So how much distance this particle is moving to get this height? The height, say this height, and the other particle. So 0.375 and 0.375 in each case. So 0.375, this is 0.375 meters. And this is again 0.375 meters. So when the particles are at the same height, the string breaks. The string breaks. So if I ask you what is the height of particle A, say this is the position A1, and say this is the position A2, and eventually from A2 it will come to the ground. If this is B, say this position is B1 and this position is B2. So after reaching B2, when the string breaks, it will move further in the upward direction due to gravity. And eventually, after reaching the maximum height, this particle will come to the ground. This particle will 0.375. After reaching the maximum height, this particle again will come to the ground. It will move a bit in the upward direction and then eventually it will come to the ground. And this right from here will move to the ground. So first we need to know, okay, what is the height of the particles above the ground when the string breaks? So simple, this much is 1 plus, so 1.375 meters. 1.375 meters is the height of the particles A and B. So I can say this is from B1 to B2. And then it will move further and eventually it will come to the ground. So the question is find the difference in the times. Find the difference in the times find the difference in the times that it takes the particles to hit the ground. So eventually both particles are hitting the ground. So to answer this is a question of 6 marks. We need to know, we need to discuss the motion of the particle. So we need to know what is the velocity at this particular instant when it reaches here at B. So without knowing this velocity, you can't answer this question. So initially the particle is at rest. So I'm making the groups from A1 to. So motion of A. I'm going to discuss the motion of A. Motion of A from A1 to A2. So remember from A1 to A2, initially uh, it was at rest. Both particles are released from rest. So U is equals to 0. And yes, acceleration for that motion when they were connected before the string break is 3 meters per second square. And uh, the distance it moved from A1 to A2 is clear. From A1 to A2, the distance is 0.375. So 0.375 is the distance moved, 0.375, and V is question mark. This is the velocity at A2. So equation which you can apply here to AS equals to V square minus U square, 2 into A into S, 0.375 is V square, which is VA square, which is at A2, and minus initially 0. So from here, velocity at A2 is, when you simplify, it is 1.5 meters per second. So when the particle reaches here at A2, it is moving with 1.5 meters per second. 1.5 meters, and as they were connected, so when particle reach from A1 to A2, B is from B1 to B2. So at this particular, so it is same 1.5 meters per second square. So 1 point from B1 to B2, it is 1.5. So this is B2 position, and this is 1.5. Now, then from A2 to the ground. So when the string breaks, the particle moves under gravity. So you can't use the previous acceleration. From A to the ground, 1.5. This is the initial velocity for the next motion, 1.5 meters per second square per second. And acceleration is not 3, but it is the particle is now moving under, due to gravity. So the acceleration due to gravity as moving down, it is plus g, means 10 meters per second square. And for next, the distance moved by particle from A2 to the ground is 1.375. 1.375 is the distance moved by the particle from A2 to the ground. And the question is, time is question mark. Time is question mark. So here you can use the equation S equals to ut plus half at square. So the distance 1.3, 1.375, u is 1.5, which is the final of the previous motion from A1 to A2, into time is question mark plus half into A, which is 10, and then t square is t square. So this is a free fall object. It's moving under gravity. So expression I'm taking as 10 for the downward motion. So I can simplify 1.375 is equals to 1.5 t plus 5 t square. You can further simplify 5 t square plus 1.5 t, and minus 1.375 is equals to 0. So when you solve this quadratic equation, so TA, the time taken by A to move from A to the ground is 0.395 seconds. The other value of T is negative, so just ignore because time cannot be negative. So this is how you can find the time. So this is the time taken by the particle A to reach the ground after the string breaks. So the string breaks when they are the same height. So next, coming to the B particle. So B1, from B1 to B2, it is moving with the acceleration of 3 meters per second. So the things are common. So the velocity, the speed at A2 is same as at B2. So now I can discuss the motion from B2. So motion of B from B to the ground. So there are two methods. So you can directly manage the situation from B to the ground. We know the initially same as the previous the velocity at A1 is same as the speed at not at A1, it was A2 and B2. So V at A2 is same as speed at B2. So the initial is 5 meters per second and acceleration. So as it is first moving up and then down, so it is initially moving up. It is initially moving in the upward direction. So I can show first it will move forward, upward, and then it will come. So as it is moving upward initially, so acceleration due to gravity in this case, I can take as minus G means minus 10. And the distance, okay. Now, eventually after attaining the maximum height, B after attaining the maximum height, B after attaining the maximum height will come to the ground. And the ground is below the level of the projection or the initial level. So what is the height of B2? What is the height of B2 above the ground? So as it is below, so for this case, as it is below, for this case, what you can do, you can take, so this length is from this position to this position, it is 1.375 again because both particles are the same height. So as the final level is below the initial level, so and particle was initially moving in the upper direction, and for that reason minus 10 is the acceleration. So S I can take as minus 1.375. So instead of finding the time to reach the maximum height and then coming from the maximum height to the ground, so this is a shortcut to this. You take distance as negative because the initial is above and the final level is below of that, and particle is eventually is hitting the ground, so minus because the final level is below the initial level, and time is again question mark. This is time for B. So time is question mark. Again, S equals to ut plus half at square. You can apply S equals to ut plus half at square. S is minus 1.375. So it's a very special technique. 1.5 into T. So keep in mind that this is for B plus half into A, which is minus 10 because initially it was moving in the upper direction. And then time is question mark. So you can simplify minus 1.375 is equals to 1.5 T minus 5 T square. And you can write in the standard form. So we have the quadratic equation, and this you can solve for the value of T. One answer of T is coming as 0.6954, and the other is negative. You'll have to ignore that negative because time cannot be negative. So just ignore this part, take this answer. So time taken by the motion of B from B to the ground. So the time taken by A to reach the ground is here. The time taken by the particle A to reach the ground is here. And the time taken after the string breaks, and the time taken by B to reach the ground after the string breaks is here. So the question was, find the difference in the times that it takes the particles to hit the ground. So 0.395 and 0.6954 are two different times. Time taken by B is obviously greater because it is first moving up and then coming to the ground. So the difference of the time I can write here. Required distance, difference of the times, 0.6954 minus 0.395, 0.395, 0.6954 is equal to 0.3004, simply 0.3 seconds. This is the time taken by, this is the time, this is the difference in the times that that it takes the particles to hit the ground. So we have the answer to this question. So this is the difference of the times. So we need to calculate the time taken by the particle A to reach the ground after the string breaks, and the time taken by the particle B to reach the ground after the string breaks, and the difference of these two times was required. So with the answer. Thank you.